Right, so let's take each one of these. We've got to identify the region. I think we already know what the region is. But let's shade the bits we don't want this time. So, which line is the x plus 4y equals 21 line? How can we check that? So, x plus 4y equals 21. No? Cool?
I believe it's the green one.
You think it's the green one? What would be your reasons for that?
I can't put into words.
What's a line not? A line. Good, I like this. Yeah. What is a line?
Infinite number of lines.
So if I pick a point on that line and it works in the equation, that equation must be right for it, yeah? As long as I don't pick a point that is on two lines, because then I won't know which is which. So for instance, Gordon thinks it's the green one. So I'm going to pick a coordinate that I know the coordinate. So I'm going to go down here. Which one's that one there? What do you think? Yeah? I know the coordinate there. So let's pick that point here. What do we think the coordinates are? You've got it on your page as well. Was it? 4, 5 or 5, 4? Good. So we've got 5, 4, which means when x is 5, y is 4. So if Gordon thinks that that works is that one,
That does not work.
then we can do 5 plus 4 lots of 4 should equal 21. So 5 plus 16 does, right?
Oh.
Got lucky.
I did not think. I forgot to multiply by 4. I didn't.
So actually we're all good. Yeah, the green one is x. Oh, do that, do I? The green one is x plus 4y equals 21. So all I need to do now is I'm only allowed the bit that's less than 21. So which one's that? Well, x plus 4y equals 21 is the green line. So I've got points that are above the line and I've got points that are below the line. And they're above and below, well, one of them will be less than 21, the other one will be greater than 21. It seems to make sense that if I pick above it, it's going to be greater than 21, right? Because, well, if x stays the same, but y gets bigger, it's going to end up being bigger than 21. So I could check, well, let's just go through, check. I'm going to actually pick that point, because that point is 4 and 5, this one. So let's just check. So 4 plus 4 times 5 is 4 plus 20, which equals 24, and that is greater than 21. So I'm only allowed where it's less than 21. So what do I do with this side of the line? Shaded it, right? So I'm going to take my highlighter and move it into. Yeah, why? Oh, sorry. Yeah, no, you're right. So let's just check. Maybe we got it wrong. So it's actually 2 and 5. So now it's 2 plus 20.
Still works.
Which is still, yeah. But well done for pointing that out. So although my calculation was incorrect, still 22 and not 24. So it's still the right side. We got the right side. So we'll still go back and shade that side. Right. So that's this one done. Covered that. All right, should we pick an easier one this time? What about the x is greater than or equal to 0, x is less than or equal to 15? How do I show that on this graph? Lester? The black line here is at 15. I've got to have when x is less than 15, so we have to shade the right hand side, so we can shade that. Now you notice how I'm shading all the way down. I'm not stopping at any of the other lines because when I'm doing it one at a time, I don't have to worry about it. What about, how do I sort out this x also has to be greater than or equal to 0? Where's that? It's not the blue one, though. It's not the red one. X has to be greater than or equal to 0.
That means that the x value has to be more than 0.
And how do I see that on my graph?
That would be the line that goes on x equals 0.
Which
the
is?
axis line.
All right, good. X is 0 is the y-axis, right? So I haven't drawn that line in because I didn't need to, because there's already a line there, it's the axis. The y-axis is x is 0, right? So if I go above that, I'm sorted. The next easy one is the y has to be greater than 0. Which line is for that? The red one. So if we've got to be greater, we've got to be above it. So shading this in. So we've got 2 possible regions left. So that means we have currently done that one and that one. Now the trick there is, well, there's only one line left, so it has to be that one, right? So this line is the minus 4x plus 6y has to be less than or equal to 0. So if that bit is the equal 0, which side of the line do I want?
You would shade above.
Okay, we want where it's less than 0. So let's just do a check, just in case. Gordon thinks we get rid of this side and keep this side. Should we use this same point here? Let's do 2 and 4. So let's put it into this. Is that the one I'm allowed or not allowed?
It's greater.
So minus 4 times 2 plus 6 times 4. Alright, so that's negative 8 plus 24, which equals 16. Is that greater than or equal to or less than 0? Greater. So that side is greater than 0, so I want less than 0. So I am going to have to shade in that side of the line. Now just to be sure, I'm going to shade all that in. There we go. I am left with a particular region. Right. Now in the past, we've just put an R in there, yeah? But I asked you for homework, didn't put it on ManageBack, so I'll have to take some blame for that, to find the integer points that work in that region.
There are so many.
Are there? Well, I'm allowed to pick the lines. Why am I allowed to pick the lines?
Because greater than or because greater or less and slash or equal.
Yeah, the and equal thing means I'm allowed to pick anything on the line. If they were dotted lines, not allowed to. But let's go through. Let's just pick some integer values. 0, 0.
Yeah.
Yeah. Let me just. So 0, 0, 2, 0, 3, 0. That's 4, 3, 1. I have got a lot, haven't I?
Yeah.
Got loads of them. And then find on that line, and then same thing above here. So all these are integer values. Alright. Yeah, you don't see. But I stop at that point because that line. I can pick this one. That one works. I'm going to go out along the line. Now, there's a reason why I'm not going to bother with the rest of them in here. It's because of one thing, which is, what's the question? Optimize this function. What did optimize mean?
Make it as simple as possible.
Not simple. Maxed out, yeah. Find the biggest value of p you can using the numbers in that. Now I've added something to this, which is integers, just to try and keep it simple, because we're doing it on paper, but actually it doesn't say integers on there. So what we're going to do is we're going to go through integers, and then we're going to say, well, what happens if it's not using any value? Right. So logically speaking, I want to know the largest value of p that can happen, which is p is found by doing 50 lots of x plus 20 lots of y. Each point within that region represents an x and a y that can be used, yeah? Have to be used together. I can't pick any x with any y. I can only pick x's and y's that represent a point in that region. So logically speaking, what do I want to do with x and y? Oh, I can't get rid of it. I've got to pick a value to put in place. Do I pick small values or do I pick big values?
Big.
Why big? Because I'm trying to max, yeah? I've got to do 50 lots of x and 20 lots of y. Now, if I look at this region, all right, where do you think the best value is going to be? Pick. Which one, x or y, is the most important in the value of p?
The x.
Why the x?
Because you have a greater potential value.
Yeah.
So I thought
50 lots of x, but only 20 lots of y. Now what we're trying to do is find the combination that gives us the maximum value of p, thinking that x is going to be bigger, have a bigger impact than y. So which area of the region do you think we should go to?
I believe it would be a point on the green line.
So, here?
No. I thought it would be best at 7 and 3.
Okay, so what we're trying to do is we are trying to find the biggest value of x that's possible, and then work out how many y's we can have on top, right? What's the biggest value of x I can have?
15.
15. Right, so here's 15, but y is only 0 there. I can go up though to
1.
Is that bigger than 15 and 0? Yeah. So this point here looks like, now let's just check that. So we know that when x equals 15 and y equals 1, that is a possibility, yeah? So if we do p equals 50 times 15 plus 20 times 1, what do we get as the p-value there? Feel free to get calculators out if you need. Stare at me. You shouldn't need to, but you can. Right, if we worked it out, do we think it's 770? Is that what you think? Yeah? Maybe? Can we just confirm then? Just check with your calculator that you get the same thing. If you don't, let's figure out why. Can you do it? Everyone do it? Everyone? You got 750. Anyone got anything different? Well, I tell you what, let's do it by hand. So 50 lots of 15, well that's 50 lots of 10 and 50 lots of 5, yeah? What's 50 lots of 10? 500. 50 lots of 5? 5 times 5 is 25, with the 10, 250. So that's 750, but 20 lots of 1 is plus 20 does make 7. I agree with 7. Right? So we think this. Now what we should do is just check. Now this one makes no sense to go to. Why? Because it drops an x and we don't gain any y's, so it must be smaller. Yeah? If we drop another x, we can go up a y. So what about that one? What do you think, guys, logically speaking? Go from here, that we think is the highest, we've gone down from 15x, x is 15, to x is 13, but we have gone up a y, right? We've gone from 1, right, y is 1 to y is 2. What do you think? Is it even worth working that one out? Why not?
You need to
Nick?
optimize the x.
And why would, what? So we've lost 2x, Sam, gone.
We lost 100 when we dropped 2 x's, but we only gained 1 y, which is only 20.
Perfect. Short of your answer, but just a little bit better. Well done. We lost 2 x's. We wanted to optimize the x. We lost 2 x's, which is losing 100. We did gain a y, but gaining a y only gains us 20. So at this point, so that means if I were to go down even further up to there, same thing every time, isn't it? Lose 2 x's, so there's no point. So do we think this point here, that's it, yeah? So I optimized it by saying x is 15, y equals 1. But that's only for integers. Dang. If it wasn't integers, what do you think? If it could be any decimal numbers at all? It's not a big jump in logical reasoning, this. Is that your hand up, Sam? Be brave. Put your hand up. So what do you think?
I think it would be where the green line intersects the black line.
You're there, aren't you? It makes sense, right? What about this point here? Do you think that still maximizes the x
Yeah.
and
Why?
adds a little bit more on the y? So that blue point here will be better, yeah?
Yep.
Now, if we think that's the region, how do we find what those coordinates of that point is? Yeah.
Well, it's on a perfect line that follows the y-axis, so that's,
Doesn't follow the y-axis. What's that line here?
that's,
What 15?
that's x.
X equals 15. So what does that mean? The coordinate of that point here is 15 something.
1.5.
How do we figure out what it is? Well, we can read it on the graph. We think it's 1.5.
Yeah.
Is there any other way of checking that that would be true?
Is it?
We've got equations here, haven't we, that work? So we've used the x equals 15 one, and which is the other line that we say it meets? Was it the x plus 4y equals 21 line? This one? Difficult to see because I've shaded it in. Should we just check then? Alright, let's just check. When x, so what did we say? X plus 4y should equal 21 because it's on the line, so it's equal. Does that work? Well, let's put 15 for x. 15 plus 4y's has to equal 21 because that point is on both lines, so I can use 15 in both. How do I figure out what the 4y must be? Josh has been good at this, so I'm not going to ask him, I'm going to ask someone else. Someone else type in. What do you do at this stage to figure out what y has to be?
So,
Well done. Let's subtract the 15. Right, subtract the 15 gives me 4y's equals it's not a big job, 21 minus 15. What? 6, good. Now I divide by 4, good. So I'm left with y equals 6 divided by 4, which if we're good at simplifying fractions ends up being 3
over 2.
over 2, which is 1.5, yeah, 1.5, 1.5. So we actually think x is 15. Now that is truly optimizing it. And what do we actually get? Well, we get p equals 50 times 15 plus 20 times 1.5. Well, we know that 50 times 15 is 750, so what do we add? Don't stare at me, do it.
You would add 30.
1.5, lots of 20. 1.5 of 20, one of them is 20, half is 10. 1.5, 30. And what does P come out as? 708. An extra 10, look, just for a half and 1. That makes perfect sense. So, I've optimized. Alright, so if you've written that, you've all written that. So, go back to the question. Optimize P equals 50x plus 20y given the 4 constraints. The constraints are the inequalities, things I'm not allowed to have. Do you remember when we drew all our equations out before, if we had this number of cakes and blah, yeah, that kind of stuff? So that was where these constraints come from. Things like it can't be less than 0 because negatives don't apply, that kind of thing. All right, any questions about that? No? Makes sense? All right, on Teams, you've got this activity. Before you get the computers out, yeah? Just pay attention. You're going to go on to it. All right. It's linear program level 1. You've got lots of writing. Now, it says the information is to be shown shading unwanted regions. So that's the way round we want it. All right. What inequality described the region showing at least 7 single rooms? Well, you've got to read the question and decide, right, whether x is the rooms, whether y, so which is x, single rooms or double rooms, yeah? And you've got to write the equation, but also as an inequality. So you'll see, for instance, there must be 20 rooms in total. So if x is your single rooms and y is your double rooms, what would you write for this one? So x plus y, no more than 20, so it must be well, I'll tell you what, I'll let you have a think about it together when you've got it on the screen. So open up your laptop, onto Teams. We've done this kind of stuff with the equations. Let's do something together. If you've got a good idea, you can help us out. Right. You are a wealthy property investor and you wish to build a hotel with no more than 20 rooms. What does that mean? Obvious question, obvious answer. Can't go above 20, right? Can it be less than 20? Yes. Okay. What must it be more than? 0. Got that? It says, market research has shown that you should have at least 7 single rooms and at least 10 double rooms. What does at least mean? Greater than or the same. This information is shown by shading unwanted regions. So, we've already discussed that it could be no more than 20 rooms, so it could be less than 20. But it needs to be more than 7 or 7 single rooms and more than 10 or equal to 10. You've got to define what x and y is going to be. What should we go with? Single rooms are x. Double rooms are y. Good. Let's go for the whole thing. So if I just write that down, right? Single. So I'm just saying, do you remember when we did this with forming equations, we defined our variables. Single is x, double equals y. That's what you've decided. It could have been the other way around, but it makes perfect sense. What inequality describes the region showing at least 7 single rooms? X greater than or equal to 7. There you go. So if I put X must be greater than or equal to 7, okay? If I plot that, that's what it looks like, right? It's got nothing to do with doubles. But let's have a look at double rooms. What inequality describes the region showing at least 10 double rooms? Y must be greater than or equal to 10. What inequality describes no more than 20 rooms? No, that doesn't make. Yeah, because X is the number of single rooms and Y is the number of double rooms. So if I add X and Y together, the answer must be less than or equal to 20. Now if we plot those, this is what we get. And you'll notice that there is only a very small region available. Yeah. Okay. Does that make sense? It's not hard, right? Logical reasoning, put it down. All right, what does the question then ask us? The question, the linear question, is optimization. The hotel rooms will cost 80 per single night. Right, 80 per single per night and 120 per double per night. What combination of singles should be built? Well, which room has the most impact? Doubles, so the Y's this time, yeah? So I want to maximize my Y's and then think about how the X affects it. All right? So if we look at our region, what's the maximum Y I can have? There, yeah? What's that? 13. And how many X's? 7. 7 and 13. Now, I can go down to this point and have one less double, but one more single. Is that worth it?
No.
Why?
You have to lose maximize.
Because you lose 120 and you only gain 80. So the point that we're looking for is that one there. All right? No point going anywhere else. So the question says, number of single rooms, 7. Number of double rooms, 13. Check that. All good. All right. Level 2. I presume they get a little bit harder. Over to you.